Hello, so this is a revision video for IB Chemistry S2.2.14, Formal Charge. This is for AHL students only. The formal charge of an atom in the Lewis structure is a hypothetical charge that we assign to an atom in a molecule. We assume that the electrons in all covalent bonds are shared equally between the atoms. To calculate the formal charge of an atom, we take the number of valence electrons it had at the start, subtract the number of non-bonding electrons it has in the Lewis structure, and then minus half the number of bonding electrons it shares with other atoms. A preferred Lewis structure will always have the smallest possible formal charges on the atoms, and it will try and avoid the same charges on atoms next to each other. Ideally, more electronegative atoms have a negative formal charge, and the total charge of all formal charges should give the overall charge of the molecule or ion. Because of this, we can determine which is the most accurate Lewis structure for a particular species by looking at the formal charges assigned to each atom in it. For example, if we take an NO2 molecule, we can see there are two ways we can represent this as a Lewis structure. In the first, we can have single bonds between the oxygen and nitrogen with one lone electron on the nitrogen atom. And in the second, we can have a double bond between an oxygen and a nitrogen and a single bond between the other oxygen and nitrogen. And again, the nitrogen has a single unpaired electron. How can we determine which is the best representation? Well, let's look at the formal charges. In the first structure, the nitrogen formal charge will be 5 minus 1 minus 4 divided by 2. Because the valence number of electrons for the nitrogen is 5, because it is in group 5, and it has one non-bonding electron. And there are 4 bonding electrons around it, meaning 5 minus 1 minus 4 divided by 2, given a formal charge of positive 2. The oxygens are both identical here in terms of their electron arrangement, and their formal charge will be 6 minus 2 divided by 2. Because their valency is 6, they have 6 outer electrons to start with, and they each have 2 bonding electrons with the nitrogen, given a formal charge of minus 1. So in the first structure, we have positive 2 formal charge on the nitrogen, and we have a negative 1 formal charge on each oxygen atom. In the second structure, the formal charge of the nitrogen is going to be 5 minus 1 minus 6 divided by 2. Because again, the valency of nitrogen is 5 outer electrons to start with. Again, it has one non-bonding electron, but this time it has 6 bonding electrons around it. So therefore, 5 minus 1 minus 6 divided by 2 equals 1. However, in this structure, the two oxygens are different. In the first oxygen, the formal charge is going to be 6 minus 4 divided by 2. Again, a valency of 6, 4 non-bonding electrons, and 4 bonding electrons. This gives a formal charge of 0. In the other oxygen, we have 6 minus 2 divided by 2. Again, a valency of 6 non-bonding electrons this time, and 2 bonding electrons, given a formal charge of negative 1. So which of these structures is better? Well, structure B only gives 2 atoms with a formal charge that isn't 0, whereas structure 1 gives 3 atoms of a formal charge different to 0. And the formal charges are also larger in structure A compared to structure B, meaning we've minimized formal charges in the second structure compared to the first. So the second structure B is a better representation. However, remember, it is still only a representation. It isn't a perfect reflection of the bonding taking place. As useful as Lewis structures and formal charges are, it's very important to remember that they do have limitations.